All right, in this video we're going to look at using the quadratic formula to solve quadratic equations. Now we've just got done working with factoring or using square roots methods of solving quadratics, but occasionally you come across a trinomial that cannot be factored. So there's this really nice formula called the quadratic formula, and believe it or not, it actually completes the square for you. You may have learned that method as well, completing the square. Well, typically we don't complete the square on many of these questions. Instead, we just use the quadratic formula. Because if I were to take the time to show you the proof for the quadratic formula, I would complete the square in the middle of the proof using all these letters. So let's understand what the quadratic formula is, and then we're going to practice using it. So given a quadratic equation, y equals ax squared plus bx plus c. Now actually I need to erase that y because I should have written, what should I have written there? 0, right? Because we're always setting it equal to 0 when we're solving quadratic equations. I was just getting a little ahead of myself. We'll be graphing these in the next few sections. So when it's set equal to 0, we have a number out front of the x squared. We're calling that a. We have a number out front of the x, we're calling that b, and we have a number here at the end, we're calling that c, the constant at the end. The quadratic formula says, insert dramatic music here, the answers are the opposite of b, so you change the sign on b. Some teachers say negative b, I like to say the opposite of b. So if b is negative, you write positive. If b is positive, you write negative. Plus or minus. Remember, we often get two answers on quadratics, so that plus or minus is where those are going to come from. Giant square root of b squared. Now, so that number will always be positive, so whenever you square b, you're going to get a positive. Minus 4, so the number 4 is always there, no matter what, times a times c. So we write minus 4ac. All of that, a giant fraction bar, 2 times a. So we write 2a on the bottom. The opposite of b, plus or minus, giant square root, b squared minus 4ac, all over 2a. So this sounds really complicated, right? It really isn't after you do a few of them. We just plug and chug out as much as we can. There is another vocabulary word, and the vocabulary word is the discriminant. The discriminant is the b squared minus 4ac part. So why would they give that a name? It's because if the discriminant is negative, you get no real solutions. They're all complex or imaginary. So if this is less than 0, we get 2 complex solutions. If it's greater than 0, we get 2 real solutions. And if it's equal to 0, we get 1 real solution. So it's often on tests and quizzes is how many solutions will you get. You can just look at the b squared minus 4ac part. Just look at the discriminant. Let's solve some of these quadratics. All right, so I'm not going to factor this. In fact, it is not possible. If you were to try to factor that, it can't factor. So we got to go to what's called the quadratic formula. So first thing is we harvest out the a. A is 1. B is negative 4. C is negative 2. And we literally plug and chug to the best of our ability out the answer. So the quadratic formula is negative b plus or minus giant square root of b squared minus 4ac all over 2a. By the way, I have a Math Minutes video that I made like 3 or 4 years ago that's really good. So I'll link to it at the end of this video. So it uses like giant boxes where you're putting the numbers in. So that may help you understand how we're going to plug in at this point. So the answers are, there's no factoring, we're just plugging in. It would be positive 4, because that's the opposite of b, plus or minus the square root of negative 4 squared. So here's the b. We got to put b squared here. So that would be 16, right? Negative 4 times negative 4 is positive 16. Minus 4a, a is 1, c. So c is negative 2 in this question, all over 2 times a. 2 times 1 in this problem. So most of the time, it actually comes up to be 1 for a. So it's pretty easy to plug that in. I think on this next one, you see here a is going to be 2, but we'll get to that in a moment. So we're really close to the answer, folks. 4 plus or minus the square root of 16. Now here's where I call the danger zone, right in here. This is the danger zone. You got to be really careful, folks. All right, because a lot of students get the sign wrong here. What is negative 4 times 1? Well, that's negative, right? Actually, let's do this a little differently. Let's do sign first, number later. That's one of my mantras I like to do. What do you get when you take a negative times a positive times a negative? What do you get? Well, we have an even number of negatives, so it's a plus. Sign first, number later. So the number later part is the 4 times 1 times 2. That's plus 8. All over 2. All over 2. All right, so underneath the radical, I'm going to come up here because we're kind of running out of room. 4 plus or minus the square root of 24 all over 2. So if you get that as your answer, I'm pretty happy. All right, we could type that in the calculator, by the way, and get our 2 irrational, non-repeating answers. But this can be simplified. We worked hard on learning how to simplify radicals. And radical 24 is the same as radical 4 radical 6, which is 2 radical 6. So I'm going to write that in there. I'll do that in red so it stands out what I just did, hopefully. See what I did there? Radical 24 simplifies to 2 radical 6. And then look at all these numbers that are outside the radical jail. Only these numbers. Don't worry about the 6. Are they all divisible by something? Yeah, they're all divisible by 2. So I'm going to divide everything by 2, and I get 1 radical 6 all over just 1. So you know what? I'm just going to put a box around that. That's really the best answer. So if this were a multiple choice problem, I can guarantee you that 2 plus or minus radical 6 would be the answer. Now to get the decimal, if they want the decimals, you would split it into 2 plus radical 6. You would type that in your calculator, and 2 minus radical 6. But very rarely do we do that. We usually just keep our answer in this form right there. All right, let's go on to number 2 now. So number 2, you see, we have to harvest out our A. A is 2. Our B is negative 4. Our C is negative 3. Okay, let's just start plugging in. So I'm not going to rewrite the whole formula each time. Okay, so let's just jump into it. The opposite of B, plus or minus the square root of B squared, is always positive. Be careful how you type that in the calculator. Negative 4 squared is positive 16, always positive. Okay, here's the danger zone, so I always take my time here and think through it very carefully. All over 2a. All over 2a. So this is 4 plus or minus the square root of 16. Okay, here's the danger zone. Take your time. We've got negative times a positive times a negative. That's, once again, that's a plus, right? And then 4 times 2 is 8. 8 times 3 is 24, all over 4. So this equals 4 plus or minus the square root of 40, all over 4. That is 4 plus or minus. Again, we practice simplifying radicals. Is there a perfect square in there, or can you take out any pairs? Yeah, 4. 4 times 10. So radical 4, this is radical 4 radical 10, so that's 2 radical 10. Again, I'm pretty happy if you get any of these last 2 answers, but look at this. These 3 things that are outside of the jail, let me circle them for you. These 3 things are all divisible by 2. So I think the best answer would be 2 plus or minus radical 10 all over 2. And just leave your answer like that. I don't really care what the decimals are. All right, moving on. We're making great progress here. What about number 3? Number 3. Well, we got to get everything to one side first. So x squared minus x plus 1 equals 0. You got to get everything equal to 0. And then a is 1, b is negative 1, and c is 1. Let's start plugging in. I'm going a little quicker because I know you don't want this to take a 60-minute video here. So x is the opposite of b, plus or minus the square root of b squared is always positive. So negative 1 times itself is positive 1 minus 4ac all over 2 times a. So x equals 1 plus or minus the square root of 1 minus 4 is negative 3 all over 2. Uh-oh. How's this one different than the others? We're not allowed to have a negative under a radical, right? That's not real. That's not a real number. These are called imaginary numbers or complex numbers. So we end up rewriting it as 1 plus or minus I radical 3 all over 2. Now everything outside of jail is the 1, the I, and the 2. Are they all divisible by something? No. So that's the final answer right there. That's how you write it. 1 plus or minus I radical 3 all over 2. Notice that the discriminant, I mentioned that vocabulary word earlier, the discriminant was negative. And I said up top here, when the discriminant is negative, you get imaginary or complex solutions. All right, how about this one? You might pause the video and give this a quick try, and then you can check your answer. All right, so we move everything to one side. Try to factor that. It cannot factor. 25 times 1, 5 times 5. None of those add up to negative 8. So let's see what happens. A is 1, B is negative 8, and C is 25. So the opposite of b, plus or minus the square root of b squared is 64 minus 4 times a times c. Again, take your time there, all over 2 times a. So this is 8 plus or minus the square root of, this would be 64 minus 100 all over 2. Well, that's 36, negative 36, in fact. So how do we rewrite the square root of negative 36? It's obviously imaginary, so how do we rewrite that? Well, 36 is a perfect square. So it's 6i over 2. And then everything in this problem is divisible by 2. So 4 plus or minus 3i is the best answer here. The best answer here. Okay, let's move right along. We've got one more question here. How would we do this? This is a quadratic equation. It's got a left side, right side. There is an x squared in it. It's just hiding. So what do? We want to move the 5 over, but not yet. Not yet. We have to FOIL this out, or you can use the box method if that's what you prefer. X squared plus x minus 2 equals 5. First thing you do is get rid of the factored form on the left so that we can fold that 5 into the negative 2. I then subtract the 5 on both sides. X squared plus x minus 7 equals 0. All right, and you might try to factor that. What multiplies to be negative 7 but adds up to be 1? Nothing, unfortunately. The factoring method is the best, along with the square root. The last resort is either completing the square or the quadratic formula. But as I mentioned at the beginning of this, the quadratic formula completes the square for you. That's what it's doing. It's just doing it behind the scenes. All right, so here we go. A is 1, B is 1, and C is negative 7. The opposite of B, so I write negative 1. Plus or minus the square root of b squared minus 4ac all over, giant fraction bar, 2 times a is just 2 times 1. Okay, so we get negative 1 plus or minus the square root of, now that is 1 plus 28 all over 2. So that is negative 1 plus or minus the square root of 29 all over 2. There's nothing we could simplify, so that's the answer right there. I do have a question down here. I put a thought-provoking question. What does the discriminant of a quadratic tell us about its solution? I let the cat out of the bag there at the beginning of this video. When the discriminant is negative, we get two imaginary or complex solutions. When it's positive, we get two real answers. We didn't see any examples here, but when it equals 0, let's add that in. I forgot to put the 0 there. I'm glad I came back up. So when it equals 0, we get one real solution. And I didn't come across one of those on here. But there you have it, the quadratic formula. All right, well, I really hope that you found this video useful. Like I said, I will link to that other video, my Math Minutes video, that goes through this, and that might also be helpful. All right, well, I wish you well, and until next time.